The past 60 years have shown clear evidence of this issue and its causes. With an increase in temperature, populations of species such as the Centrostephanus, which thrive in warmer waters, are also increasing. This adds more pressure to an already imbalanced ecosystem, as endemic natural predators cannot control these populations in the same way they can control Kina. To continue to study these population imbalances, there is a need for new technology.
We're starting to do quite a lot of work with underwater imagery and photogrammetry, so stitching images together to make large three-dimensional models of the seafloor that we can then relate sea urchin abundances to kind of physical characteristics like rugosity and slope. What we're looking to do is bring in AI to help with that analysis side of things, so we're taking away the manual need to go through and score imagery and allowing a computer to basically recognise what a sea urchin is, recognise what a kelp forest looks like, and then make those decisions automatically.
These methods may provide a viable solution to the sea urchin counting problem. In terms of decreasing the population of Kina, clearly the best and most durable method is to increase the predators by establishing new fishing quotas and creating marine protected areas. However, Kina removal is an initial shock to the ecosystem that works as a restart to allow regrowth of kelp forests.
If you can combine sea urchin removal at the beginning to jumpstart that recovery, and so you see those kelp benefits early on, but you have additional protection that will allow those sea urchin predators to recover.
Although removing Kina may seem detrimental, it has been shown that sea urchins living in Kina barrens are less healthy due to the lack of available food.
You get probably the biggest and healthiest urchins in healthy kelp forests, but you get more urchins that are less healthy in barren areas. Even if you're just diving and you just take one off a rock, taking one off a rock in an urchin barren is usually pretty easy because they're just really weak. Then taking them off in a kelp forest, they're really strong and they'll latch on. Just in general, you get healthier Kina in kelp forests.
Therefore, if removal is necessary, new and more efficient methods need to be developed. The current one-by-one removal by divers is useful for scientific purposes, but it's not feasible for large-scale eradication. The challenge lies in how to remove Kina without harming other species. After discussing the issue with Nick and Kelsey and spending some time in this context, new ideas have emerged. Specifically, the possibility of using sound at certain frequencies and amplitudes to create fractures in Kina shells seems worth exploring. These ideas will be proposed to our scientists to discuss if these techniques would be feasible.
A lot of different points of view when it comes to harvesting and culling of Kina, as you would with any species. There's a lot of good points of view for that, but yeah, there's almost never a straightforward answer.
After learning more about this issue that is prevalent not only in New Zealand but around the world, this field of study will benefit from new ideas as well as from international collaborations.
I think realistically, it's really hard to change people's mindsets. While I guess I'm still pretty young and excited and I'd really like to change that, there's a lot of work that needs to be done at the top levels for any of that. We can do the science and we can say, but we actually need people at the top to be listening.
The source of this issue is a result of human impact, and it's our responsibility to find solutions and restore balance to this important ecosystem.